This is Ham College, episode 93 for September 30th, 2022. This episode of Ham College is brought to you by Icom. Keep your competitive contesting edge with Icom. Good evening. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And it's good to be back with you tonight. We've already warned the pre-show crew here that it's going to be a bumpy ride tonight. There's well, this particular section has a lot of questions. But before we go there, I thoughts and prayers to everyone down in the South Florida area. Especially around Fort Myers where they just took a major hit. It's, tough situation. But
no doubt.
We're going to talk about some ham radio questions here, and these are on the extra amateur radio class exam. What did we talk about last month?
It's a good question. Oh, yeah. I recollect now that we talked about digital circuits, digital circuit principles and logic circuits, classes of logic elements, positive and negative logic, frequency dividers, and truth tables, to tell the truth.
Yeah, that was it.
That was it.
And tonight we're going to talk about amplifiers, or classes of operation, vacuum tube and solid state circuits, distortion and intermodulation products, spurious and parasitic suppression, microwave amplifiers, and switching types. There's no way we can cover 18 questions and do any explanations at all in a single show, so we're going to cut them in half. We're going to do the first half of the question. We're going to do the 9 questions. Then we're going to come back and do the splaining, because there's 6 pages of splaining here. Power amp classes are letter symbols for the different power amplifier types, and they help define an amplifier's characteristic and performance. The classes are related to the time period the active amplifying device is passing current. And they normally think about this as a sine wave. You know what a sine wave looks like.
Mm-hmm.
I'm sure everyone here studying for their extra exam does. So that's what they're basing it on. A Class A amplifier is going to conduct for the longest period out of all of them. I'm not going to give the number because you'll know it already, I'm sure. And it's going to be the purest signal, Class A. All right. Class B steps it down a notch. And I think, well, the question we just asked was AB. So Class B, it conducts less than Class A. I'm not going to say the exact number here again because that'll give away some of these questions. Class C conducts even less than A and B, and we'll talk more about that later. And there's also a Class AB, which is the question you just had. Mm-hmm. Well, no, wait a minute. They said, a Class AB. That's a push-pull amplifier, because that's what the question said there. But we'll talk more about push-pull amplifiers. And a Class D amplifier is another type that's, it's come about in more recent years. That's an amplifier that operates sort of in a switching mode. So you really don't look at the time period of like that sine wave to determine the class of that amplifier. And D does not stand for digital. It just happened to be the next letter after C. Seriously. At least that's what I read.
Okay. You read on the internet?
Yeah.
It's got to be true.
Gotta be true. What portion of the signal cycle does each active element in a push-pull class AB amplifier conduct? A, more than 180 degrees but less than 360.
B, exactly 180 degrees.
C, the entire cycle.
Or D, less than 180 degrees. Ooh. For what portion of the signal cycle does each active element in the push-pull AB amplifier conduct? I have no idea. For which portion of this signal does each active element? The one that seems somewhat obvious would be B. Although I got a funny feeling that's probably not right. This portion of the signal cycle, 180 degrees would be half of it. And as a push-pull, I'm going to go with B. I'm really not sure though. That's just a guess. I don't know this stuff in this topic very much, and I didn't study.
They're a little mixed between A and B here. So I didn't see anybody answer anything else. So I'm going to pull the lever here, and we're going to see what it was. More than 180 degrees.
I kind of had a funny feeling about that one, but that really doesn't make much sense to me. I don't understand the principle behind it.
I got a funny feeling about all of them tonight.
Well, there's some buzzer going off, so you may want to get some earplugs or put some cotton in your ear.
I mean, I know a little bit about it, and we have actually talked about some of this before, as we'll find out later in the show, but it came back around on us.
And bit us.
Yeah.
At least half of us.
So, congratulations on the first buzzer on the show. It won't be the last.
I'm sure Probably. It won't. What is a Class D amplifier? A type of amplifier that uses switching technology to achieve high efficiency.
B, a low-power amplifier that uses a differential amplifier for improved linearity.
C, an amplifier that uses drift mode FETs for high efficiency.
Or D, a frequency doubling amplifier. So really, I shouldn't have said all of that right there, should I? I just gave away.
It was quite convenient for you since you had the next question.
Well,
it's okay.
I'm just saying.
I'm sure you already knew them anyways. It's fine.
I think it worked out to everyone's advantage.
Well, we want everyone that's watching to succeed, so it's okay.
Yeah. So, all right. And I just said what it was, and I already knew what it was, and apparently everyone over there in the chat room knows what it is.
Apparently
everyone that's answered, and all of them aren't answering, so we don't know about that. But I'm sure anyone who does, they're going to say it's a type of amplifier that uses switching technology to achieve high efficiency.
Well, if they said Class that, they would be right.
Yep. And we'll talk more about Class D amplifiers later in the show here. And there. That's what it is. So everybody in the chat room, there.
Fist bump.
You got a fist bump. Which of the following components form the output of a Class D amplifier circuit? Is it A, a low-pass filter to remove switching signal components?
B, a high-pass filter to compensate for low gain at low frequencies.
A matched load resistor to prevent damage by switching transients.
Or D, a temperature compensating load resistor to improve linearity. Which of the following components form the output of a Class D amplifier circuit? Low pass filter to improve switching signal components.
To remove
switching
Yeah.
signal components. Since it's switching, I'm going to go with A. A low pass filter to remove switching signal components.
Yeah.
What's everybody else saying? A's
Yeah.
and stuff.
Yeah.
Well, that's what I'm going with.
All right.
I don't think it's any of the other three. I'm pretty sure it's A.
I'm
Could be
going
wrong.
to agree with you. It's a low-pass filter to remove switching components. So there.
Where on the load line of a Class A common emitter amplifier would bias normally be set? A, approximately halfway between saturation and cutoff.
B, where the load line intersects the voltage axis.
C, at a point where the bias resistor equals the load resistor.
Or D, at a point where the load line intersects the zero bias current curve.
Oof.
Where on the load line of a Class A common emitter amplifier would bias normally be set?
I'm glad you got this because I have not even a clue.
Well, I don't think it's D. And I don't think it's C. So that's down to A or B.
That is?
To me, since I don't think it's C or D. Where the load line intersects the voltage axis. Well, wow. I don't remember this. So,
halfway between saturation and cutoff.
yeah. So I'm going to say it's B.
Intersects.
Where the load line intersects the voltage axis. Chat room?
There you go. Most of them got A's.
Yeah.
Hey.
Hey,
Welcome to the club.
what did I say?
B.
No, I didn't. Did I?
Play it back.
Okay, I must have said B.
You did.
Okay. What can be done to prevent unwanted oscillations in an RF power amplifier? A, tune the stage for maximum SWR.
B. Tune both the input and output for maximum power.
C, install parasitic suppression and or neutralize the stage.
D. Use a phase inverter in the output filter. What can be done to prevent unwanted oscillations in an RF power amplifier? Well, tuning it for maximum SWR will probably work after it burns up and it doesn't do anything anymore after that. So that's probably not what you want.
No, I don't think
It's not a desirable effect.
I would agree. That's not.
So it's not A. Tune or B would be tune both the input and output for maximum power. Input and the output. I don't think that's it either. C. Install parasitic suppressors and or neutralize the stage. That seems plausible. D. Use a phase inverter in the output filter. I'm going with C on this one.
It's
Yeah,
not
C.
as tough as you were saying earlier.
Well, when you first glance at the list, at just the questions, and you don't read the answer things, yeah, it's pretty tough. Like, but when you see the multiple choice answers, a lot, not always, but sometimes you can kind of reason through them. Which of the following amplifier types reduces even order harmonics? A. Push push.
B, push pull,
C. Class C.
or D, class AB. Well, this is a little hard.
Push push. That's what happens when you run out of gas.
Yeah. Okay, so this is going to be hard to explain at this point until we get later into the show where we do the explanations. Which one reduces even order harmonics? I'm going to say it's D, class AB.
Okay.
And
what's your reasoning for that?
my reasoning is I know a class AB wait a minute. The class AB is a push-pull, isn't it? Isn't that what you had on your very first question tonight? Push-pull, class AB.
Yeah.
Yep. So in that case, there could be two different answers there that are the same thing. But I know definitely it is not class C.
Okay.
Because class C is, that's on down the chain there. That's a dirtier amplifier. Push, push. No, it's not that. Wow, well, that kind of confuses me that you got a push-pull or a class AB, but I'm going to go with class AB. I could be wrong on this. What are they saying over in the chat room? B, D, C.
Everything but A.
Yeah.
This may be a banner evening for the Ozino team over here.
Tom says, I get it. A class AB operates and push-pull would work, but a single element in AB would be nasty. Yeah. You're right, because you could have a single element class AB amplifier. And you wouldn't have the two halves of the signal canceling each other out, or the harmonics out. Okay. Wow. You're winning. Let me see if I can
yeah, don't worry. I'll
here.
catch up and pass you.
Which of the following is a likely result when a Class C amplifier is used to amplify a single sideband phone signal? A. Reduced intermodulation products.
B. Increased overall intelligibility.
C. Signal inversion.
Or D. Signal distortion and excessive bandwidth. Or E. You don't know. Which of the following is a likely result when a Class C amplifier is used to amplify a single sideband phone signal? Well, Class C is worse than a and a B. Reduce intermodulation products. I don't think that's it. B. Increased overall intelligibility. I think the opposite would be the case then. Signal inversion. I don't think so. D. Signal distortion and excessive bandwidth. That's got to be the answer. D. Signal distortion and excessive bandwidth. And I didn't cheat because you see my screen went off right there.
Yeah.
Of course, there's a lot of answers on there. I'm going with D. It might not be it, but that's the one up there that makes sense to me.
Signal distortion and excessive bandwidth.
That makes sense.
Yeah. You know, like we were saying earlier, as you come down the alphabet there, the amplifiers get worse. Till you get to Class D. And then you don't rate, it's not
Then it's
rated the same.
digital.
No, it's not digital.
Well, it's used for...
It's the fourth letter in the alphabet. That's why they did that. But yeah, you can kind of think of it that way. Although the splaining I read said it's not because of that. Anyway.
Okay, here's one for you. How can an RF amplifier be neutralized? A, by increasing the driving power.
B, by reducing the driving power.
C, by feeding a 180-degree out-of-phase portion of the output back to the input.
D, by feeding an in-phase component of the output back to the input. Wow. How can an RF power amplifier be neutralized? It's not A, by increasing the driving power. It's not B, by reducing the driving power. So then you got your choice. You can put an in-phase or out-of-phase portion of the output back to the input. Let me think about that for a second. If I put I should know this.
I think I know what this one is.
Because I have to neutralize amplifiers at work. My transmitters, the tube type ones, have to be neutralized. Feed out of phase back into the input. It's going to do some cancellation. I'm going to go with that. It's C. By feeding a 180 degrees out of phase portion of the output back to the input.
You nailed that.
I stumbled around and got it. Yeah.
You still nailed it.
Yeah.
Ooh.
Which of the following describes how the loading and tuning capacitors are to be adjusted when tuning a vacuum tube RF power amplifier that employs a pi network output configuration?
I just had to open my mouth up, didn't I?
It's a breeze, man. You got this. A loading capacitor is set to maximum capacitance and the tuning capacitor is adjusted for minimum allowable plate current.
We're going to be tied tonight. B, the tuning capacitor is set to maximum capacitance and the loading capacitor is adjusted for minimum plate permissible current.
C, the loading capacitor is adjusted to minimum plate current while alternately adjusting the tuning capacitor for maximum allowable plate current.
D, the tuning capacitor is adjusted for minimum plate current and the loading capacitor is adjusted for maximum permissible plate current. The loading capacitor is set to maximum capacitance and the tuning capacitor is adjusted for minimum allowable plate current. I don't know. I think it's C or D. I'm going to guess C. Okay. But I don't really know.
I know the procedure here because I have to do it a lot.
Well, alternately is what I'm thinking.
Yeah.
I think you would go back and forth and adjust each one till you got it basically perfected or where it needed to be. I don't know, man. Well, C is what I'm guessing.
I do go back and forth alternately. But I'm going to disagree with you. I think it's D.
I don't doubt it.
Chat room, everybody was C or D. So, 50-50. Let's see.
Tied.
It's D.
This is a 4-buzzer night, man.
You just don't get that kind of entertainment every show.
Not for free.
No, not for free. Well, I can see here some splaining is in order. Some of this stuff we're just not going to really splain tonight. We just went through all the questions we're going to cover tonight. We're going to take a quick break and be right back, and we're going to do a little splaining on what some of these are. But I was going to tell you before we take that break, the way I tune an FM transmitter. You got a loading and a tuning. Mm-hmm. In your linear amplifiers, most of them tube types will be similar to this. You know, number one, follow what the manufacturer tells you to do when adjusting one, unless you are the manufacturer. All right, so plate current, or actually plate tuning and plate loading's the two knobs you got. So you're going to dip the plates with the plate tuning, and then you're going to peak the output of the amplifier with the plate loading. Now, in this case, that's not what they said. The loading capacitor is adjusted for maximum permissible plate current. Well, that is true, because when the amplifier is putting out the most, your plate current's going to be the highest, adjusting the loading capacitor. But you want to dip it, or find a dip, or where you've got minimum plate current on the tuning. And I go back and forth between the two. And yeah, you don't have to do it that often, but now on your linear amplifier, whenever you change frequency on a tube type amplifier, you're going to have to retune it. Unless you just slightly change. It's going to change a little bit as you change frequencies. I think I'm going to have to take a quick break, run up here to the tap, and we'll be right back.
Keep your competitive contesting edge with Icom. Icom's high-powered base stations cut through pileups, letting you work the bands and record those contacts. Contest from the comfort of your home or remotely with the RSBA1 app. Heard it, worked it, logged it. The IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing inherent noise in different IF stages. The IC7300 changed the way entry-level HF is designed. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The real HF fun starts here. Create your own band opening with the IC9700. This transceiver brings direct sampling to the UHF-VHF weak signal world. This all-mode transceiver is loaded with innovative features that are sure to keep you busy. Faster processors, higher input gain, higher display resolution, and a cleaner signal. 4.3-inch color touchscreen TFT LCD, real-time high-speed spectrum scope, and waterfall display. Smooth satellite operation with 99 satellite channels, dual watch operation, and full duplex operation in satellite mode. Icom's IC7610 is the SDR every ham wants. This high-performance SDR can pick out faint signals in the presence of stronger adjacent signals. The Icom 7610 is a direct sampling, software-defined radio that has changed the world's definition of an SDR transceiver. RF direct sampling system, 110 RMDR, independent dual receiver, dual digicell. Icom's IC7851 gives you a new window into the RF world and is HF excellence unparalleled. With faster processors, higher input gain, higher display resolution, and a cleaner signal, it's truly the pinnacle of HF perfection. Dual receivers, digital IF filters, memory keyer, digital voice recorder, high-resolution spectrum waterfall display, enhanced PC connectivity, and SD memory card slot. Learn more about all these great Icom radios at icomamerica.com/amateur.
I notice you've got a red shirt
It matches.
Right here.
It almost matches my blue shirt.
And before we beam down, we should probably.
But this isn't like Star Trek. This is a desirable red shirt.
Well,
you
it
wear
is.
this red shirt, you're gonna be all right.
Yeah.
It's not like the landing party with
True.
the red shirt.
Okay,
Guy
yeah.
Never makes it back to the ship ever.
Well, it's not the Star Trek crew. It's the ham crew.
Yeah, that's better.
The Icom ham crew.
That's even better.
So, if you wanted one of those,
You mean one of these?
just
want
like
one.
that.
I got one.
Well, here's what anybody but you or I need to do. You send an email to hamcollege@AmateurLogic.TV. Two things. You got to have an email address and you got to have a name.
I got those.
Most everyone watching tonight has those.
Pretty much.
Don't have to have a call sign or any other stuff like that.
What are you going to do with my email address if I send it in? You going to sell it to somebody?
No, we're going to save it till we do the drawing right before each episode of Ham College. We're going to choose a random winner there, and then we're going to delete all the emails. I am going to print out the email of the winner, though, just long enough that I can read it here on the show. Because a lot of times they'll give us a good note in there. They have more than just a name and an email address.
Oh, those are good. It's not required, but if
Not
you put a
required.
note in there, we do like to read them.
Yep. And tonight, this one comes from Bob, W8RMV. Bob is our lucky winner tonight.
Awesome.
Bob's subject on his message, he said, I need a shirt for cutting the grass. You could use it for that.
You can cut the grass with that if you want.
Yeah.
If you want to.
And then down in the body of the message, he says, or when I'm operating my IC7610.
Well, it's even better for that than it is for cutting the grass.
It
It's
is.
perfect for a 76
Yep.
stand.
Thanks, guys. Well, thank you, Bob, for watching and for entering the contest here.
Yeah, congratulations.
And Icom will be in touch and get that out to you right away.
Thanks to Icom for supplying the cool swag to give away.
Exactly.
And sponsoring Ham College.
And sponsoring Ham
So,
College.
anyway, I didn't get to use the looking as good when you leave the Ham Fest as you did when you got there line this time, but I'll save that for next month.
Or while you're mowing, you'll look as good coming as you do.
Go all the way around the whole yard.
Exactly.
That's true.
All of your neighbors, you'll look just as good to them. Okay, we got some explaining to do. We've been through all the questions
You
now.
do.
First thing we're going to talk about is the advantages of a Class A amplifier. Remember we said there were A, B, C, there's an AB, there's a D, and there's other classes of amplifiers as well that have come about in more recent years.
But the Class A is the best.
The Class A is the best.
That's all we want is the best on here.
Yeah, we don't always get that, but
that's what we like.
a Class A amplifier, let's just look at some things about it. This is a solid state one here, but you know, Class A can be a tube type or a solid state amplifier, either one. You see on the left-hand side there at the base of the transistor, you've got a sine wave.
Mm-hmm.
And over on the right-hand side, we're seeing an amplified sine wave. It's the same wave, only bigger because it was amplified. Class A is the best class of amplifier. It's even better than the Class D and some of the others because the Class A amplifier is conducting, the device is conducting 360 degrees of the cycle. So that sine wave, that transistor is switched on in this example and operating for a full 360 degrees of the cycle, the 100% of the time. The drawback, though, is it's only 25 to 30% efficient.
Oh.
So you waste a lot of power with that. The benefit, it's the lowest distortion of all the amplifier types. Why wouldn't you use a Class A amplifier for everything?
Not enough output?
That could be one reason. There's a number of reasons.
Tell me, Professor.
Well, first we'll talk about the advantages. Class A can be built with a single device, as in this example right here. In other words, it's not a push-pull amplifier, so you only have to have one device. Some will have more than that. The amplifying element is biased, so the device is always conducting, and it's operating in the most linear portion of the transconductance curve. So that means where the transistor is operating its best, we've always got the amplifier biased right there, or the device biased to where it's operating in its most linear region. Because the device is never off, there is no turn-on time. It's on all the time, so there's no problem with charge storage, and generally gives you better high-frequency performance and feedback loop stability, and usually few higher-order harmonics. The point where the device is closest to being off is not a zero signal. So the problem of crossover distortion associated with A, B, and B designs is avoided. And this amplifier type is the best for low signal levels of radio receivers due to low distortion. Sounds like a lot of good reasons that you'd want a Class A amplifier right there.
Mm-hmm.
There are disadvantages. Class A is inefficient, as we said earlier, 25 to 30%, I believe. A maximum theoretical efficiency of 25% is obtainable using usual configurations. Oh, so it doesn't even make 30% according to the explaining I got here. In a power amplifier, this is not only wasted power, it limits the operation with batteries. And it increases operating cost, requires higher current devices. It's inefficient. So not only is it wasting power, it's heating up. So the device, you're going to have to, the cooling requirements go up because the device is running hotter. Class A power amplifier designs have been largely replaced by more efficient designs. Their simplicity, though, makes them popular with hobbyists. There is a market for expensive high-fidelity Class A amplifiers that they're considered cult items among audiophiles, mainly for the absence of crossover distortion and reduced odd harmonics and high-order harmonic distortion. Class A amplifiers are also used in some boutique guitar amplifiers because of their unique tonal capabilities, quality, and reproducing vintage tones. So there are still out there, but you won't run across them very much in amplifiers. Now, the article that I took this from Wikipedia, they were talking mostly about audio amplifiers, but all this stuff applies to, yeah, it's still pertinent. So the next amplifier class that we are going to talk about is Class B, which is a push-pull amplifier. It differs in that instead of 360 degrees of the time, it only conducts 180 degrees. That means it's more efficient than a Class A, and there's also more distortion than a Class A. You can see we got two devices there. They are being fed and amplify opposite halves of the signal. One is amplifying the positive half. The other is amplifying the negative half.
Mm-hmm.
There are some advantages to that. The device doesn't have to be turned on all the time. You're turning on one and then turning on the other, so it's not going to get as hot. That's one advantage there. Also, there are some disadvantages as well, though, because where it splits there and splices the two halves of the wave together, on the right-hand side there on the sine wave, you can see each one is only doing half of that sine wave, opposite halves. Those have to be assembled back together to get the full sine wave that you're going to be listening to, or the output of the amplifier. At radio frequencies, it can be used if it's coupled to the load via a tuned circuit. A single device operating in Class B can be used because the stored energy in the tuned circuit supplies the missing half of the waveform. There is another class that's very similar to that, Class AB. That means it's not quite as good as the Class A amplifier. It's not top of the class, but it's not a beast unit either. It's kind of floating in the middle there.
It's like an A minus or a B plus.
That's a push-pull design there. And you can see that top transistor in this circuit is only doing the top half of the waveform, the positive half. The other transistor is only doing the negative half. They are biasing these different. In the Class B amplifier, each transistor only conducts 180 degrees of the time. On a Class AB, each of those is conducting a little more than 180, somewhere between 180 and 360. So they bias those transistors so that they stay switched on for more of the duration of that waveform, but not a full 360 degrees. So it's more efficient than a Class A because neither transistor is turned on all the way all the time. And it's lower distortion than a Class B because you don't have the crossover distortion. Where in a Class B, you're switching one on, switching the other off, constantly doing it like you were saying a moment ago, you know, to get both halves of the signal. In a Class AB, each one stays on a little more than half of the signal or half of the waveform there. So when they're spliced back together to give you the sine wave out, there's no gap or crossover distortion or very little compared to a Class B amp because you got more to put back together. In other words, the signal never really goes all the way down to zero before the other half comes in. So when they put them together, rather than you got a top half and a bottom half and the others, you're just trying to kind of, you know, put them together right there, and you could have some distortion where they're joined.
Yeah.
In a Class AB, there's a slight amount of overlap there. So they two halves of the signal join together better. But maybe that's not the best way to say it. So
Well, I understand.
yeah, Class AB sacrifices some efficiency over Class B in favor of linearity, because 78.5% of the full amplitude sine wave in the transistor amplifies typically much less in common Class AB vacuum tube amplifiers. It's typically much more efficient than a Class A. Yeah, and a Class AB is always going to be a lot more efficient than a Class A. Not quite as efficient as a Class B. So you'll find Class AB amplifiers are used quite a bit.
Yeah.
Because it's not the best, but it's generally good enough. You know, probably
Sounds more practical too.
Yeah,
in most cases.
those are used a lot in hi-fi amplifiers and you know, in some ham radio circuits and amplifier designs as well, because it's a good trade-off between the two. Get better efficiency without sacrificing much quality of the signal. And, oh wow, we got another type to talk about here. Class C amplifiers. And I'll cut to the chase because there's an awful lot here about Class C. There's a Class C amplifier. In this case, it's just using a single transistor there, or a single tube. And you can see you put a signal in on the right-hand side of sine wave. On the output over there, you've only got half the waveform. And it really is, it's not even as wide as half the waveform. You see how it's kind of sloughed off there?
Yeah.
And it does come down to a peak or a dip at the same point there on the curve. It's not as good. Distortion-wise, you're going to hear this. Class C amplifier conducts less than 180 degrees. So it's not even doing a full half of the waveform there. It's turned on less than 180 degrees or half. It's more efficient than a AB or an A or a B, but it's got more distortion than all those as well.
What would you use that for?
Well, those are useful if you really want an efficient amplifier. A Class C will work for that. It's going to be nasty as all get out.
You could handle that much distortion.
Well, that's a good question. And you could never get away with using that on an AM or sideband amateur radio rig,
No.
I mean, it would be blatantly obvious that you sounded awful, and all your neighbors up and down the band wouldn't really appreciate it that much either.
Yeah.
How
Marty said drive-through speaker mics.
probably yeah,
Sonic or whatever.
could be.
Yeah. They're pretty poor.
However, they are used in some FM broadcast transmitters.
Really?
Yeah,
For what?
you would think, how could that work?
How could that work?
Well, if we look at the picture there again, that's a good question there.
I'm glad
On
you
it-
thought of it.
On an FM signal,
Yeah.
all we're really interested in from the amplifier is just the time period of the signal. In other words, if we put in, say, 100 megahertz, we want to get a signal that's out is also 100 megahertz.
Mhm.
It really doesn't matter if it's an exact replication. Like we see right here, that's not even half the waveform, but it's at the same rate. So in other words, if we put 100 megahertz in on the left-hand side, we've got a 100 megahertz signal coming out the right-hand side. You follow that? Because on
Yeah.
an FM, using it as an amplifier, we're not that concerned about
But
it.
again, this is just for the carrier.
No.
For the audio?
Yeah, on FM. Because on AM, we've got a signal out here. And when we modulate it, the signal is increasing or decreasing. And so we've got to replicate that amplitude, pretty much the same. A Class A amplifier will do that, as it swings above and below the zero crossing threshold. Class A is reassembling that perfectly.
Mm-hmm.
Class B, not quite as good. Class A, B, somewhere between
Pretty
the two.
good.
Class C, man, it's only going to do like half.
Mhm.
It would sound horrible
Mm-hmm.
on AM or amplifying a sideband signal, and it would be all over the place. But on FM, you're not that concerned about it. When you come out of, say, your tube or your transistor circuit, you're doing a lot of filtering on it, and all you really need to replicate is just the frequency. You don't care about the quality of reassembling that sine wave or the oscillator, because the oscillator is not always sitting right there on 100 megahertz. On FM, instead of swinging up and down as you change the modulation, it's going left and right.
Yeah, I
so
see.
it's swinging above and below the carrier frequency. So it doesn't matter if the signal is not a perfect sine wave or whatever it is, because all we're looking at is the frequency of that signal, not the amplitude. So,
Interesting.
I hope that made sense. So, big FM transmitters, big tubes, you'll see Class C amplifiers in them. And you think, wow, that's got to be nasty. But no, it's not really. You got a harmonic filter on there.
Because you're only interested in certain properties of it.
Right. You're only interested in the frequency, not the actual quality of the signal, but what frequency it's on.
That's pretty interesting.
Yep. We got one more that we're going to cover. Like I said, there are a lot of different classes of amplifiers. But one in more recent years, it is very popular now.
Mm-hmm.
You will see these all over the place now because they've got some pretty good advantages to them. That is a Class D amplifier. It's using pulse width modulation, or could call it pulse density modulation or delta sigma modulation. You put your signal in, and then that signal is clocked out with a switching controller. It's like digital. They don't call it that, but essentially it's very similar. What we're doing, we've talked about pulse width modulation before, That's what's happening here. You're taking your amplifier and you're turning it all the way on or all the way off at a much higher frequency than, say, if we're talking about audio, at a much higher frequency than the audio. Or if we're talking about RF signal, we're switching it on and off constantly from off to on, 1 or 0. We're doing that at a much higher frequency than the actual frequency we're wanting to amplify. So what that does is it allows it to recreate, and I wish I had some better pictures here, but it allows it, at the end of it, you take that pulse width modulated signal and you filter it to get off all of the trash, all the switching signal, everything above the desired frequencies, you're filtering out. So when you look at it with the proper filtering, it is actually reproducing what you put in. Although you put in an analog signal and you're getting more or less a digital signal out, you're trimming off the digital part of it, the higher frequencies that it's switched at. Why would you use a Class D?
Oh, they're highly efficient.
Oh, you saw where I had the pin laying there. They are. Because the amplifier is only on or off, it doesn't have to be on that much, just depending on what the input is. Class D can be up to 90% efficient. So that's almost, if you're using a battery, that's like almost 100% of that battery is nothing but the signal you're trying to produce. There's no waste in heat, negligible waste there.
Mm-hmm.
So it's just very, very efficient. And also, they're low distortion. They don't produce a lot of distortion. Now, it is not as good as a Class A amplifier, because that's the best, but it's a very close second. It's better than an AB.
Yeah.
It's right up there. So we're seeing a lot of those today because we've got chips and things now that can do that. You buy a new power supply, 12-volt power supply, and it's very light. That's pulse width modulating. Your cell phone's probably Class D on the audio amplifier in there.
Mm-hmm.
I'm not sure about the RF amplifier in it. They're Class D linears now.
Oh, yeah?
Yeah. Because they're much more efficient. They don't run as hot. The little speakers that you buy with the battery-powered speakers, Bluetooth speaker, all of those are Class D.
Huh.
Anything battery-powered today is probably going to be a Class D, anything new, because it's just so efficient. That's how they can take something really small and put a battery in it, and you can charge it up, and the thing lasts forever. Because it's not wasting hardly any of that in heat. It's all going to your output.
Cool
So,
stuff.
yeah, there's a lot of stuff you can look up there. I noticed in the chat room they're talking a good bit about this, and yeah, a lot of good information there, but I can't.
Well, we may have got 4 buzzers tonight, but I feel like I learned a lot in class.
Yeah, well, that's good.
Yeah.
I'm glad you did, because that's about all I got to say about that.
It was plenty.
It was plenty. That's what I was thinking. I was wondering if I would get through it. Yeah.
It was a lot, but it was good information, though. I appreciate you going through the trouble of doing that.
Well, you're welcome.
Pretty good stuff.
So, because I did that and you learned something, I tell you what, why don't we take a break, come right back, because people are really going to want to know how they can win your radio over there.
Around the 15th of each month, it's Amateur Radio's original and longest-running video podcast, AmateurLogic.TV, with hosts George Thomas, Tommy Martin, Emil Diodene, and Mike Morneau.
Roughly, here's what I have. The bottom trace here is ground.
while the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas.
I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
What about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack and went outside. The house lost power. The whole neighborhood went out for about 30 minutes. I don't know what happened.
Wow. That explains a lot. Now we can take this and put it over inside our box. It's flush to the bottom. If we were to rotate, we can see that thing goes all the way through, so we'll have a hole in the bottom.
What ammunition do you use in there?
Actually, you can use black powder, you can use WD-40, you can use, anything combustible. You just have to use the right quantity, and we assume no responsibility for mishaps.
Here's what it looks like after I've got them all soldered together and heat shrinked up. Okay, let's give it a try and see how it worked out. So there you have it, the hula loop. No, you can't null out the dogs barking.
I have 2 thin film solar cells to run this. Looks like a little mini weather satellite, actually. And I'm using guitar string for the antennas.
I particularly like that last one there, $29.99. You can get a 50-foot garden hose extension cord combo.
Do not get cord wet.
Now, most of these J-poles are built with metal elements or tubing. The reason I chose wire for this one is the length of this particular one, so I wanted to hang it from the tree so I can hoist it up there.
Yeah.
Go fishing.
Well, we couldn't find the reel.
Yeah.
Is that what that is?
All right, Tommy, sing the theme song here.
Marty mentioned one thing over in the chat room. I just briefly skimmed back through that. You see a lot of Class D amplifiers being used in PA systems today.
Oh, yeah.
It's hard to buy PA speakers that don't have amplifiers built in them anymore. You can't just hardly find a passive speaker. I guess you can, but they're more difficult to find. That's because in the old days, before we had Class D, there's no way you'd want to pick up a big speaker that had, say, a 400-watt amplifier or something like that, and it'd just be so heavy you couldn't put it up on a stand. Now you can get them with 1,000 watts, and they just don't weigh much of anything. So
Technology is amazing.
It is. So what we're going to talk about here, so we've got something to give away besides just a T-shirt. Do you believe that?
Yeah, I believe it, because I know what it is.
Yep. Coming up next month, October 15th, will be, the 17th anniversary of AmateurLogic. Still hard to believe.
It really is.
We're going to celebrate by giving away a complete ham station here. This is what you want right here. If you do any portable operations at all, or it'd be good as a home station as well.
Mm-hmm.
Icom and MFJ are teaming up with us, and we're going to give away a sweet prize package there. What are the prizes, Tommy? What's on the list?
Well, we've got an Icom IC705 transceiver. We've got an MFJ 2389 8-band compact antenna, as you can see on your screen. MFJ 4230 MVP 12-volt power supply. And some RG8X to go along with it from MFJ.
And if you'd like to win this, because who wouldn't, we're going to be giving it away on the next episode of Amateur Logic. We'll stream on Friday the 14th of October. You got to be qualified to enter and win. The first qualification is you've got to be a licensed U.S. or Canadian amateur radio operator with a U.S. or Canadian shipping address.
The second one is only one entry per contestant. Sending more than one entry will disqualify the applicant.
The winner is responsible for any taxes incurred.
The winner agrees to the use of his or her call sign and name in promotional and use item related to the contest.
And the contestants must not be an employee or affiliate of AmateurLogic, Icom, or MFJ Enterprises. You know, it's let's talk a little bit about those prizes. That has ended up being a pretty sweet radio. Well, it came out as a pretty sweet one and just keeps getting better.
Yeah. Yeah.
How do you like yours?
Oh, this one's actually mine. So this is not the one you're getting. So I'm not giving mine up. If I had to get down to one radio, heaven forbid, this would be the one that I kept because it's got everything in it that I need.
Yeah.
It's up to 10 watts if you use external power on it. It's a SDR touch screen, so you can basically touch the screen to operate it like the 7300. A lot of the newer Icom radios. It's really awesome. I love it. We used it at field day, or I did. It works off a battery, the same batteries as ID51 and ID52. There's also got a bigger one that you can get for it. It worked. We worked field day with it. Barely even made a dent in the battery. I have no idea how long it would run on that 50 amp battery, but I'm assuming probably months and months.
It would probably still be running.
I believe it would.
Yeah. It's HF, 50 megahertz, VHF and UHF multi-mode.
Yeah.
So what all modes can you do with that thing?
You can do. Well, here, let's take a look. We can do. Sideband, CW, RIDI, AM, FM, digital voice, which is D-Star, wide FM, and data.
Most all of the frequency bands that most hams operate on, and most of the modes as well. Not every one, but way more than most other radios.
Yeah, so it's a maximum of 5 watts out with the built-on battery. It's a little handy talkie style battery, but if you hook up external power, 13.8 volts to it, then you can get up to 10 watts out on it. Yeah.
RF direct sampling system for the SDR. There are real-time spectrum scope and waterfall display built in it. As you can see the waterfall running right now. Large touchscreen display, color touchscreen. You saw Tommy poking around, tapping that thing.
Yep.
It's compact, lightweight. You know, for portable, it's a no-brainer. I can't think of any radio I would rather have that you could just grab and take with you and do virtually anything with.
I'm telling you, like I said, if I had to get rid of everything, get down to one radio, this would absolutely be the one that I had.
It's got one-touch FT8 mode, wireless LAN, and Bluetooth.
Yep. Yeah, that's a great feature.
GPS.
Of
course, D-Star. And there's an optional antenna tuner available if you'd like one, or an optional backpack as well. And you have those.
I have both of those.
Yeah.
They're great match with the radio.
So you've got the full kit.
I do.
Everything.
I do.
And there's not another radio you would need, really.
Absolutely. No, it's not. Like some people may scowl at 10 watts out, but 10 watts out actually worked pretty well at field day.
It worked much better than I was thinking you would come out with, because I looked at how many contacts you made at field day this year and how many I made sitting at the same location, and it was very impressive. You running 10 watts and me running 100. And there was not that much difference between the number of check-ins or contacts that we made. Well, you might not want to run it on battery all the time.
Yep.
And that's okay, because we're going to give you a nice switching power supply. You have this power supply too.
I actually do have that exact one. The MFJ 4230 MVP compact switching power supply. 30 amp, mighty light. It's got power poles on it. got the banana jacks and the thumb terminals on the front of it right there. Super compact. The MFJ 4230 MVP is 25 amps continuous and 30 amps surge at 13.8 volts. It's also adjustable from 4 to 16 volts. And it'll run on 120 or 240 volts at 47 to 63 hertz.
You're going to want an antenna with that as well. I think we can hook you up on that. It's the MFJ 2389 vertical, compact, 8-band, 80 through 2 meters, plus UHF, 200 watts PEP. Email and Glenn have used this down in the Slidell area for, I don't know, a lot of events. Field day for the last several years, and Email's always bragging about how well this antenna worked. For something that's compact, is not that big, and you got 8 bands on it, he swears it's a solid performer, and I can't argue with him. It's less than 6 pounds. It's only 8.5 feet tall. It's good for operating with restricted space environments or possibly even an attic or balcony. And its ground radio system is built in, so you don't have to worry about having counterpoise wires. It's got an SO239 feed point connection. It's a quarter wave on HF 80 through 6 meters, a half wave and 2.15 dBi gain on 2 meters, and a 5/8 wave with 5.5 dBi gain on 440 megahertz. So a very versatile antenna, lends itself well to portable operation or, for base operation at the house.
Yeah, that's the one piece of this kit I don't have, and I've actually got my eye on that.
Yeah.
It'd be a really nice addition.
That is a pretty nice addition. So we're going to need to hook that to the radio. So MFJ is also giving us RG8X coax. I believe it's a 25-foot length MFJ 5825X.
Perfect.
So really, it's everything you need to get on the air and get going right
Very
there.
nice station.
And we're going to give that away, like we said, next month.
Entering to win is really easy. All you need to do is send an email to contest2020@AmateurLogic.TV with only your call sign in the subject line. Only your call sign in the subject line. I'm going to say that again. Include your name, call sign, class of license, and address in your email message. The submissions may be made between Monday, August 29th, which is past, and you have up until Monday, October the 10th of 2022. So time's running out. So get your entries in.
Winner is going to be selected by a random number from the entries received. So we're going to look at how many entries we had, generate a random number. Wherever that falls, that's going to be who wins it. If it's determined the winning entry does not meet the qualification requirements, we're going to choose another winner using the same method. And contest rules and information, well, you can find them at the link we showed there, AmateurLogic.TV/contest. We're looking forward to the 17th anniversary episode of Amateur Logic coming up the middle of next month. Join us then live if you can. If not, and you win, we'll be getting in touch. And, somebody's going to have a great package there. Thanks, everyone, for watching Ham College tonight, and those who watch AmateurLogic.TV as well. We always enjoy doing these shows, and we've been at it a few years now. And
just a few.
Boy, are my arms tired. Yeah. No, it's been fun. And
yeah, it's been fun. If it wasn't, we wouldn't continue to do it.
Yeah. And we look forward to seeing you back here at the end of October. But at Amateur Logic, we're going to see you on the same live stream address.
Yep. Don't forget to send your entry in if you haven't already. If you've sent it, don't send another one because more than one will get you disqualified.
Yeah. So that's going to do it. Before we get out of here, Dean, anything else?
Well, you know what? My last words on contest time is 73, and good luck in the contest.
That's good advice there. All right. Thanks for being here, everyone. We're going to pick back up on Ham College next month with the other half of those amplifier questions that we covered tonight. And hopefully there won't be as much explaining to do, but who knows? I haven't looked at the second half of the questions.
Yeah.
So
we'll figure it out.
All right.
Maybe we won't get 4 buzzers. 73, good night.
7-3. Tonight, we're going to talk about power amp classes. That's one thing we're going to talk about, just power amps in general. And that means we're going to have a power amp class at the end of these questions. And we're also going to have questions about the classes of power amplifiers.
Okay.
So it's a two-pronged approach here tonight. Yeah, they're saying B and D in the chat room. Okay, Spike, I wasn't going there.